Reality. It's something we rarely question. We experience the world as solid and real, but what if it's all an illusion? Quantum physics questions our reality. It reveals a universe of uncertainty. This challenges our definition of reality. Are we living in a simulation? Once fringe, now a serious consideration. One of the most compelling pieces of evidence for the simulation hypothesis comes from quantum mechanics. Quantum entanglement, where two particles influence each other instantaneously, has baffled scientists. Einstein called it spooky action at a distance, suggesting a connection beyond space and time. Could this interconnectedness hint at a simulated reality? In simulations, all parts are connected through code. Similarly, quantum entanglement might hint at a deeper level of reality. The probabilistic nature of quantum mechanics supports the simulation argument. These parallels have led some physicists to speculate we might be in a sophisticated computer program. The idea that our reality might be a simulation is not entirely new. Philosophers like Plato and Descartes explored the possibility that our senses deceive us. Nick Bostrom's 2003 paper brought the simulation hypothesis into modern scientific discourse. He argues that if advanced civilizations can create realistic simulations, then it is highly probable that we are living in one. This hypothesis has sparked widespread debate among scientists and philosophers. Nick Bostrom's simulation argument didn't emerge in a vacuum. It has roots in earlier philosophical thought experiments. One such precursor is the brain in a vat scenario. Imagine a brain, kept alive and stimulated to produce the illusion of reality. This is the crux of the simulation hypothesis. It posits a sufficiently advanced computer program as the source of our perceived reality. Bostrom argued that if civilizations can run ancestor simulations, simulated realities would outnumber the real one. While the simulation argument is compelling, it's important to distinguish it from pure philosophical musing. Quantum mechanics behaves in ways that often defy common sense. One bizarre aspect is quantum superposition, where a particle exists in multiple states until observed. Schrödinger's cat is both alive and dead until the box is opened. This strangeness hints at a deeper reality structure, akin to a computer game rendering only what's viewed. Quantum entanglement shows particles linked across vast distances, influencing each other instantaneously. In a simulated universe, all points are connected via underlying code. Assuming for a moment that we do inhabit a simulation, the next question naturally arises: who are the simulators? Speculation runs wild, from superintelligent AI to future humans running simulations to understand their past, or even for entertainment. Each possibility raises further questions about their motivations and the nature of our existence. Are we simply lines of code in their program? Or do we possess some form of digital consciousness, unaware of our true nature? If our simulators can intervene, do they? Are we part of some grand experiment, or merely a forgotten side project? The implications are as profound as they are unsettling. Some proponents of the simulation hypothesis suggest that there may be ways to detect the presence of our simulators, or the underlying code of the simulation. This has led to searches for patterns or anomalies in physical constants, the cosmic microwave background radiation, and even in the behavior of subatomic particles. Others believe that the very act of searching for evidence might be detectable by the simulators, potentially leading to our simulation being shut down or altered. This raises ethical concerns about the potential consequences of our actions if we are indeed living in a simulated reality. The idea of our reality being a simulation has captured the public imagination, fueled by popular culture like The Matrix. These stories feature glitches in the Matrix, moments where reality's simulated nature becomes apparent. Could such glitches exist in our world? Some point to phenomena like déjà vu, the placebo effect, or the observer effect in quantum mechanics as hints of a simulation. Others suggest inconsistencies in historical records, or impossible objects as evidence of software bugs. While intriguing, these are far from conclusive. Unexplained phenomena exist in many fields, and attributing them to a simulated reality is speculative. Extraordinary claims require extraordinary evidence. Nonetheless, the possibility forces us to confront fundamental questions about our existence and reality. To grasp the feasibility of our reality being simulated, we need to think about the universe differently. What if the universe is made of information? This is the computational universe. Imagine it as a vast computer processing information. Every interaction could be a complex calculation. Future civilizations might create realistic simulations. The simulation hypothesis isn't solely reliant on computing power. It also hinges on the development of advanced artificial intelligence. The field of AI is rapidly evolving. Some experts believe AGI could be achievable within this century. These beings could live in virtual environments unaware of their true nature. While classical computers struggle to simulate the universe, quantum computing harnesses the rules of quantum mechanics. Qubits can exist in multiple states, performing calculations exponentially faster. This could revolutionize our understanding of the universe. Though still in its infancy, it opens up mind-boggling possibilities, blurring the line between science fiction and scientific possibility. The most daunting challenge for the simulation hypothesis is replicating consciousness. Can we truly replicate the subjective experience of being alive, feeling emotions, having thoughts and desires? Some argue consciousness is an emergent property of complex systems. Simulating consciousness might be a matter of hitting the right level of sophistication. Others believe consciousness is beyond the reach of computation. This question intersects with the deepest mysteries of philosophy and neuroscience. If we are simulated beings, what does that say about our consciousness? Are we lines of code experiencing an illusion, or is there more to us? The answers remain elusive, forcing us to confront our assumptions about reality. One intriguing aspect of the simulation hypothesis is the implication that reality, if simulated, must have limits. Just like a computer screen has a finite number of pixels, a simulated reality would have a finite resolution, a smallest unit of space and time, beyond which nothing can be observed or measured. This leads to the question, could we detect these resolution limits? Some physicists have proposed experiments to look for evidence of such a pixelated reality. If we were to find evidence of such a fundamental limit to the resolution of reality, it would be a strong indication that our universe might not be what it seems. However, even if we could definitively prove the existence of a simulated reality, it wouldn't necessarily answer the bigger questions. Who are our simulators? What is their purpose in creating us? These questions would likely remain, pushing us to continue our exploration of the universe and our place within it. The simulation argument, for all its allure, rests on shaky ground for some critics. Their main issue? It might be fundamentally unprovable. Imagine trying to prove to a character within a video game that they're not real. Any evidence you present, even seemingly irrefutable glitches, could be explained away as part of the game's code. Similarly, any proof we find of our own simulation could be just another layer of the simulation itself. Perhaps the simulators want us to find these clues, or perhaps they're inevitable consequences of the simulation's design. We're trapped within the confines of our perceived reality, unable to access the code to confirm or deny its existence. This leads to accusations of the simulation hypothesis being a modern-day equivalent of philosophical unfalsifiability. While not inherently invalid, it becomes a matter of belief rather than scientific inquiry if no amount of evidence can truly settle the matter. The debate continues, challenging our understanding of reality. Even if we sidestep the provability issue, the simulation hypothesis hits a major snag consciousness. We can conceive of simulating vast universes, but replicating the feeling of subjective experience, the what it's like to be human, remains a monumental challenge. This is what philosophers call the hard problem of consciousness. Can lines of code, however complex, truly feel love, fear, or the awe of gazing upon a starlit sky? Skeptics argue that simulating behavior, even highly complex behavior indistinguishable from our own, isn't the same as generating true consciousness. A simulated person might tell you they're happy, but can they really feel it? Or are they just executing pre-programmed responses? Even if we meet seemingly conscious beings within a simulated reality, we're left with the unsettling possibility that they're merely sophisticated automatons. The mystery of consciousness remains a profound challenge. The simulation hypothesis, while seemingly cutting edge, has drawn criticism from an unexpected corner theology. Some argue that it's simply a technological reskin of old creation myths, replacing divine beings with advanced programmers. Instead of God creating the universe, we have superintelligent beings creating the simulation. Instead of divine purpose, we have the whims or experiments of our simulators. The core concept, however, remains similar, an external entity responsible for our existence. Critics argue that this simply shifts the mystery, not solves it. Where did the simulators come from? What are their motivations? Are they themselves simulated? We end up in an infinite regress, pushing the ultimate explanation further back without truly addressing the fundamental questions of existence. The theological debate adds another layer to the complexity of the simulation hypothesis. Another line of criticism invokes Occam's razor, the principle that, given competing explanations, the simplest is usually the best. The simulation hypothesis, while captivating, requires accepting several extraordinary assumptions. First, that civilizations can reach a level of technological sophistication to create such simulations. Second, that they choose to do so on a vast scale. Third, that consciousness can arise within such simulations. Each assumption, while not impossible, adds another layer of complexity. Critics argue that simpler explanations exist for our current understanding of the universe. Perhaps we haven't yet discovered the correct physical laws, or our understanding of consciousness is fundamentally flawed. Attributing these mysteries to a complex simulation might be prematurely jumping to a far-fetched conclusion. Of course, Occam's razor isn't foolproof. Sometimes reality is stranger than fiction. But it serves as a reminder that the most outlandish explanation isn't always the most likely. The burden of proof remains on the proponents to present more compelling evidence before dismissing simpler alternatives. The simulation hypothesis, despite its critics, remains a powerful thought experiment, forcing us to confront fundamental questions about reality, consciousness, and our place in the cosmos. But where do we go from here? How do we move this from the realm of speculation to something approaching scientific inquiry? This might involve searching for those elusive glitches in the matrix, patterns in physical constants, or anomalies in quantum behavior that defy conventional explanations. It also requires continued exploration of consciousness itself. Advances in neuroscience, artificial intelligence, and perhaps even fields like quantum biology might shed light on the nature of subjective experience and whether it can be replicated through artificial means. Even if we never definitively prove or disprove the simulation hypothesis, the journey itself is valuable. By questioning the nature of our reality, we push the boundaries of our understanding. Our quest for signs of a simulation leads us to the farthest reaches of the observable universe, to the faint afterglow of the Big Bang itself, the cosmic microwave background, CMB. This radiation, a faint whisper from the universe's infancy, carries with it an imprint of the conditions that existed just moments after the Big Bang. Think of it like a cosmic fingerprint, revealing the universe's initial structure. If our reality is a simulation, this fingerprint might hold telltale signs of the underlying code. Just as a high-resolution image breaks down into pixels when zoomed in too closely, the CMB might reveal a similar pixelation at the Planck scale. Some physicists have proposed that the universe's expansion, if we're in a simulation, might leave a subtle imprint on the CMB. While current observations of the CMB haven't revealed any definitive evidence of simulation, future telescopes with higher resolution and sensitivity might be able to probe these subtle effects. The search continues, pushing the boundaries of our understanding. Our universe is governed by a delicate balance of physical constants, fundamental values that determine the strength of forces, the masses of particles, and the properties of space-time itself. These constants are not predicted by our current laws of physics. They're simply observed values that we plug into our equations. The strange thing is, many of these constants seem oddly fine-tuned for life. Even slight variations would result in a universe where stars couldn't form, atoms wouldn't hold together, or the universe would have expanded too quickly for galaxies to form. This apparent fine-tuning has led some to invoke the anthropic principle, suggesting that our universe's properties are somehow selected for the existence of observers like ourselves. From a simulation perspective, this fine-tuning takes on a new meaning. Perhaps our simulators have tweaked the parameters of our universe to create conditions suitable for life. While the fine-tuning argument doesn't prove the simulation hypothesis, it highlights the unsettling possibility that our universe's properties might not be random. The quantum realm, with its bizarre rules and counterintuitive phenomena, has always been a source of mystery and wonder, but could it also be a window into the underlying code or simulated reality? Physicists believe that by pushing the boundary of experiments, we might be able to glimpse upon which our reality is built. One line of inquiry involves searching for deviations from the predictions of quantum mechanics, particularly at extreme energies or small scale. Reality is a simulation with finite resolution. Then at some point, the smooth fabric of space-time might break down, revealing a pixelated or grainy structure. Another approach involves investigating the nature of quantum entanglement by carefully studying the behavior of entangled particles, particularly over distances or extreme conditions. We may be able to detect subtle deviations from standard quantum mechanics. The quest to understand the quantum realm continues, offering potential insights into the nature of reality. The simulation hypothesis, while still firmly in the realm of speculation, has the potential to revolutionize our approach to scientific inquiry. By forcing us to question the fundamental nature of reality, it opens up new avenues of research and inspires us to look for evidence in unexpected places. Instead of dismissing it as an outlandish idea, we can embrace it as a thought experiment that pushes the boundaries of our imagination. The search for evidence of a simulated reality might lead us to develop new technologies and experimental techniques. It might also inspire us to re-examine our place in the cosmos, prompting us to ponder the nature of consciousness, the meaning of existence, and our relationship to a potential creator. Ultimately, the simulation hypothesis is more than just a scientific question. It's a philosophical and existential one. The journey itself is likely to transform our understanding of ourselves and the universe we inhabit. We've journeyed through quantum physics, computer science, and philosophy. Yet the question lingers. What if we are living in a simulation? The implications are profound and unsettling. Our perception of reality comes into question. If we're lines of code, does that diminish our accomplishments? Some find solace in a benevolent creator. Others despair, feeling like puppets. Perhaps the most rational response is acceptance. Our day-to-day lives wouldn't change. Relationships and the pursuit of happiness remain. The greatest shift might be in our perspective. Knowing our simulated nature could spark new inquiry. The ethical implications of living in a simulation are perhaps the most challenging to navigate. If our actions are ultimately determined by code, does free will become an illusion? If so, how do we hold individuals accountable for their actions? Do concepts like justice and morality still hold meaning in a simulated world? Furthermore, if we reach a point where we can create our own simulations, populated by seemingly conscious beings, what are our moral obligations to them? Do we treat them as mere playthings, subject to our whims? Or do we afford them the same rights and respect we would any other sentient being? These questions are not merely hypothetical. they're becoming increasingly relevant as our technological capabilities advance. The development of artificial intelligence and the possibility of creating conscious simulations require us to grapple with these ethical dilemmas now. The simulation hypothesis, by confronting us with these uncomfortable questions, forces us to reevaluate our moral compass. It challenges us to develop a new framework for ethical decision-making in a world where the lines between reality, simulation, and consciousness become increasingly blurred. In the face of the simulation hypothesis, one might be tempted to succumb to existential despair. If our reality is a meticulously crafted illusion, does anything truly matter? Is there any point to our struggles, our triumphs, our fleeting existence in this digital playground? This is where the true strength of the human spirit shines through. Throughout history, we've faced existential threats, questioned our place in the cosmos, yet we've never ceased to seek meaning and purpose. We find solace in love, in art, in the pursuit of knowledge, in the simple act of living a life filled with passion and compassion. The simulation hypothesis, rather than negating our search for meaning, might actually enhance it. It reminds us that even within the confines of a potentially simulated reality, our choices still matter, our experiences still hold value, and our capacity for love, creativity, and wonder remains undiminished. Whether we're living in the base reality or a simulation nested within countless others, the fundamental questions of existence remain the same.